Today we want to take a look at section 5.4, the triangle inequality. It's a pretty short section. The notes are pretty brief, so this video shouldn't take you very long. Pretty much start right off the bat with our triangle inequality, which says the sum of two sides of a triangle should always be greater than the length of the third side. So basically what we're saying is this: if we have a triangle, we've got a right triangle here. Doesn't matter if it's right, it could be acute, obtuse, scalene, whatever. But I've got a right triangle with side lengths of 3, 4, and 5. Basically what the theorem is telling you is if I take any two sides of my triangle and add them together, that sum should always be greater than the other side. So here if I take 3 plus 4, that should be bigger than 5. And it is. If I take 4 plus 5, that should be bigger than 3. And if I take 3 plus 5, that should be bigger than 4. So that's the triangle inequality theorem. And it's always going to be true. Okay, as long as we have a triangle, that theorem should always hold true, where two sides added together are always bigger than the third side. Alright? So we take a look at a couple of examples. Determine if the given measures can be the lengths of the sides of a triangle. So, to determine that, so I've got 2, 4, and 5. If I'm going to have a triangle, then two sides added together should always be bigger than the third side. Well, obviously, if I take the two biggest sides, the two biggest lengths, and add them together, they'll always be bigger than the smallest side. So, really what you need to focus on is the two smallest sides. So if I take 2 plus 4, and I add those together, is that sum bigger than 5? In this case it is. So yes, it's a triangle. Okay. 4, 9, and 12. Again, focus on the two smallest sides. Add those together. If I take 4 plus 9, is that greater than 12? Yes, it is. So I know that those three lengths can make up the sides of a triangle. 6, 11, and this is an 18 right here. So if I take 6 plus 11, is that greater than 18? No, it's not, unless you can't add. So 6 plus 11 is not greater than 18. 17, not greater than 18. So this is not a triangle. So that's where the triangle inequality theorem comes into play. If I'm given three lengths and say, hey, can those three lengths make up the triangle? I can use that inequality to figure it out. Key is focus on the two smaller sides. If the two smaller sides add up to be more than the third side, you're in good shape. So, our last three examples here. Find the range of values for the measure of the third side of the triangle given the other two. So here we're saying, hey, I know that I've got a triangle. One side has a length of 7. One side has a length of 12. So 7, 12. So this segment could be much longer, or it could possibly be much shorter. This is 7. This is 12. I think you say that side here is a lot shorter than that side here. Easiest way to go about it, add and subtract. If I take 12 minus 7, I get 5. If I take 12 plus 7, I get 19. My third side has to be between those two values. So x has to be bigger than 5, and x has to be bigger than 19. So if this side length here is 5, it's not going to work. So it's got to be bigger than 5. If this side length here is 19, it's not going to work. It's got to be smaller than 19. So example 5, I've got 22 and 34. So if I take 34 minus 22, that gives me 12. If I take 34 plus 22, that gives me 56. So I know that my third side has to be somewhere bigger than 12, but smaller than 56. last example, let you try real quick. You've got 15 and 18 as your two side lengths. Maybe pause the video right now, that way it's easier. It's an awkward silence here. So 18 minus 15 gives us 3. 18 plus 15 gives us 33. So that third side of my triangle has to be somewhere bigger than 3, but smaller than 33. So that's your notes for section 5.4. Hopefully you understood it. If not, feel free to go back, watch some of the stuff again, go through the examples again, and see if it makes more sense. And we will talk about this tomorrow when you come into class. See you then.